Welcome to the deep dive. You know, when you send a text message halfway across the globe, it arrives in like a millisecond. We just expect things to be instant. But when you try to transfer rent money to your landlord on a Friday night, suddenly it's just lost in the ether until Tuesday.
Yeah, exactly. I mean, we have this expectation of a totally digital world, but behind the curtain, well, a lot of our financial infrastructure is basically still operating like a manual switchboard.
Okay, let's unpack this. Because if you want to know why your Friday night rent check is in limbo, you really have to look at the ledger. I mean, that's basically the single source of truth for all balances and cash flows, right?
Right, it's the core of everything. And the foundation running most of our incumbent banks today, it was actually built in the 1970s.
Oh, wow. The 70s. So we are talking about really old tech.
Oh, absolutely. We're talking about legacy systems built on programming languages like COBOL. And they run on these massive physical IBM mainframes. So the defining feature of this era is batch processing.
Like end of day processing, right?
Exactly, end of day. And in these legacy systems, the data is mutable.
Okay, so let's say we have a Heritage Bank customer, Sarah. If Sarah drops off $1,000 in cash at her local branch at like 4:30 p.m. on a Friday, her mobile app might instantly show a pending balance, right?
Yeah, it looks instant to her.
But the ledger itself doesn't actually settle until maybe 11:00 p.m. when the bank runs its overnight batch script.
You nailed it. And during that overnight window, the system effectively locks active ledger rights. I mean, it processes the entire day's transactions sequentially, updates all the balances, and only then does it unlock.
So if Sarah tries to do an instant transfer at 1:00 a.m.
It might just fail, yeah, because the database is temporarily closed for business.
Wow. And that mutable part you mentioned earlier, that means they're literally overwriting the existing value in the database. It's kind of like writing a balance in pencil and just erasing it when it changes.
That's a perfect way to look at it.
But wait, if they just overwrite the data by erasing the pencil, how do they even track history or fix errors without losing their minds?
Well, honestly, it requires intense manual overnight reconciliation.
Seriously, manual.
Yeah, during those maintenance windows, they balance the books and make sure all those erased pencil marks were transcribed accurately to separate external audit tables.
Which really begs the question, I mean, if this is so clunky, why haven't these massive banks just updated their software?
Because decades of complex, entangled banking logic are tied up in that old COBOL code. Ripping out a core ledger and replacing it without losing a single cent. It's like performing open heart surgery on a running marathoner.
Yikes, that sounds incredibly risky.
It is. But erasing history and locking the system every single night naturally forces a breaking point, you know? Eventually, you need a system where history is continuous.
An always-on system.
Right. And what's fascinating here is the architectural shift from those mutable ledgers to immutable ledgers. I'm talking about append-only logs built on modern cloud infrastructure like AWS or Kafka.
Okay, so instead of one massive computer doing all the work at midnight, it's like a web of microservices talking to each other instantly. So let's look at a modern example like NeoPay. If Alex sends Taylor $50 at 2:15 a.m. on a Sunday using a modern app, how is it bypassing that 11 p.m. bank lockout?
Well, under the hood, that transaction processes in under 50 milliseconds because it isn't waiting in a queue to overwrite an old balance.
Just adding to the list.
Right. It simply creates two permanent log entries, debit Alex 50, credit Taylor 50. And because it's an append-only log, it creates what we call time travel auditability.
Time travel.
Yeah, the system can mathematically recreate the ledger at any exact microsecond in history just by reading the log from the beginning.
Okay, here's where it gets really interesting. Wait, so if I make a mistake, they can't just delete it. Like, they have to add a whole new transaction just to fix a typo.
Yep, that is the trade-off. You trade the ability to use the backspace key for absolute mathematical certainty. You can never overwrite or delete anything.
Oh, wow.
You simply append a new reversing transaction. It creates this completely tamper-proof history that can handle over 10,000 transactions per second with zero batch downtime.
So what does this all mean, like, for the average person just trying to access their paycheck?
It means these underlying architectural differences dictate the reality of what a bank can actually offer you. Legacy cores create artificial friction, right? They impose those batch delays, the weekend blackouts, the holding periods.
Right, the stuff that drives us crazy.
Exactly. Cloud-native, real-time ledgers, on the other hand, provide the foundational speed required to actually connect to instant payment networks like FedNow, or to deploy real-time AI-driven financial services.
So we're finally upgrading from balancing a checkbook by hand to a GPS system that tracks every cent in real time. But I want to leave you with something to mull over. If modern cloud-native ledgers maintain a permanent, unalterable, microsecond by microsecond log of every single financial move you ever make, what happens to the concept of financial privacy once AI is unleashed to analyze that perfectly preserved, never deleted history?